Good morning to all. Today we are discussing about negative clamper unbiased circuits. In the last class also we studied about negative clamper unbiased circuits. In that topic, for the analysis of the negative clamper circuit, we are giving the input signal is the square waveform. Okay, but in this class, for the analysis of the negative clamper circuit, we are giving the input signal is the sinusoidal waveform. Okay, the negative clamper unbiased circuit I show in figure. Okay, in this circuit, the capacitor is connected in series to the voltage source, and the diode is connected parallel to the voltage source, and here we are connecting the output terminal. In this circuit, the diode is we are considered as the either the ideal diode or the practical diode. Okay, for the analysis of this negative clamper circuit, the diode we are considered as the ideal diode. Okay, and now we are giving the sinusoidal signal is the input of this negative clamper circuit. During the positive half cycle of this input signal, the diode is on. It means that the diode is operated in the forward bias condition. Okay, now here we are considered the condition is the input voltage is greater than 0. Okay, in this duration the diode is on, means the diode is operating in the forward bias condition. Okay, based on this condition we are redraw the circuit, then we are getting this circuit. Okay, here the diode is short circuited and the output voltage V out equal to 0 volts. Okay, at that time we need to estimate how much voltage is stored across the capacitor. Okay, then the calculation of the voltage across the capacitor purpose, we are apply the KVL in this circuit, that is minus Vn plus Vc equal to 0. Therefore, the voltage across the capacitor Vc equal to Vn. Now here we are applying the input voltage equal to Vn equal to Vm. Therefore, the capacitor voltage Vc equal to Vm. Okay, and after reaching this instant, the diode is operated in the reverse bias condition. Okay, it means that after this instant means in this duration the diode is operated in the reverse bias condition. Okay, now here our doubt is how the diode is operating the reverse bias condition. For example, here we are consider the one circuit. Okay, and already the initial stage the capacitor can store the maximum voltage equal to 5 volts. Okay, and this instant the input signal voltage equal to, for example, 4 volts. Okay, and here the diode is open circuited, and this is we are considered the anode voltage, and this is we are considered the cathode voltage, and already the cathode is connected to the ground. Therefore, we are assuming the cathode voltage equal to 0 volts. Okay, and now we are apply the KVL in this circuit. Then we are getting the equation is minus 4 volts plus 5 volts plus V equal to 0. Therefore, the anode voltage equal to minus 1. Now, here the anode voltage is less than the cathode voltage, means the diode is operated in the reverse bias condition. Okay, now here in the sinusoidal signal point of view, after reaching this instant in this overall duration, the diode is off. Okay, now here we are consider the equivalent circuit of in this duration. Okay, here the diode is open circuited. Okay, and now we are estimate the output voltage of this circuit. Okay, therefore we are apply the KVL in this circuit. Okay, then we will get the minus Vin plus Vc plus V out equal to 0. We can require the output voltage of this circuit. Therefore, V out equal to V in minus Vc equal to 0. And already this capacitor initially store the voltage equal to Vm. That value we can substitute here. We will get the V out equal to V in minus Vm. Okay, based on this equation we will draw the input and output waveforms of the negative clamper circuit. Okay, these are the input and output waveforms of the negative clamper circuit. Okay, and we know that the output voltage of the negative clamper circuit V out equal to V in minus Vm. Okay, and this is the input signal of the negative clamper circuit, and this is the output signal of the negative clamper circuit. Okay, for example, here during this duration the diode is on. At the time, the output voltage of the negative clamper circuit equal to 0 volts. Therefore, here we are drawing the 0 volts. Okay. After this instant, the output voltage of the negative clamper circuit is V out equal to V in minus Vm. For example, at this instant, here we are substituting the voltage equal to 0 volts, for example. Okay, therefore here we are getting the V out equal to 0 minus Vm, then we are getting the V output equal to minus Vm. Therefore here we are mention the output voltage equal to minus Vm. Okay, for example, the input voltage V equal to minus Vm, then we are getting the output voltage of the negative clamper circuit is minus Vm and minus Vm, then we are getting the minus 2 Vm. Therefore here we are getting the output voltage of the negative clamper circuit is minus 2 Vm. Clear? And at this instant the input voltage equal to 0, then we will get the output voltage equal to minus Vm. Okay, and again during the positive half cycle of the input signal and the diode is on, and again the output voltage equal to 0. Okay, and in this way here we are getting the output of the negative clamper circuit. Okay, and now we are observing this output signal. This output signal is negative clamping of the this input signal. Therefore this circuit we are considered as a negative clamper circuit. Okay, and next we studied about if the diode is the practical diode. Okay, this practical diode model is also called as constant voltage drop model. Okay, in this constant voltage drop model, if the diode is on, it means that if the diode is operated in the forward bias condition, this diode is replaced by a constant voltage, that is the cut-in voltage of the diode is 0.7 volts. Okay, for example, if the diode is off, it means that if the diode is operated in the reverse bias condition, this diode is open circuited. Okay, now with the help of these two conditions, now we are analyzing this negative clamper unbiased circuit. Okay, and again here we are redraw the negative clamper circuit. Okay, and here we are giving the input signal is the sinusoidal signal. Okay, and again here we are giving the input signal is the positive half cycle. During the 0 to t by 2 instant, the input voltage is Vm. Okay, at that time this diode is forward biased. It means that the input voltage is greater than 0. At the time this diode is forward biased. Okay, and this forward bias condition, the diode is replaced by a constant voltage source. Okay, therefore here we are redraw the circuit. The diode is replaced by a constant voltage source. The voltage is 0.7 volts, and here we are connecting the output terminal. Okay, the output equal to 0.7 volts. Okay, but now here we need to estimate the how much voltage can store across this capacitor. Okay, that is we can answer the VC. Okay, now here we can apply the KVL in this circuit. Now we are getting minus V in plus VC plus 0.7 volts equal to 0. Okay, and now here we require the voltage across the capacitor. Therefore, Vc equal to V in minus 0.7 volts. Okay, and with respect to this condition, we need to estimate the input and output waveforms of this negative clamper circuit. Okay, and after reaching this instant, in this overall duration, the diode is operated in the reverse bias condition. Therefore, this diode is open circuited. Okay, and here we are redraw the circuit. The diode is open circuited, and now we are estimating the output voltage. Okay, and already the capacitor initially stores the voltage equal to V in minus 0.71, and here we are giving the voltage equal to Vm. Therefore, here the voltage of the capacitor is Vm minus 0.7 volts. Okay, and coming to this circuit, okay, already the diode is open circuited, and now we are estimating the output voltage. Okay, now here in this circuit, apply the KVL in this circuit, then we will get the minus V in plus Vc plus V out equal to 0. Therefore, V out equal to, we will get the V in minus Vc, and here V in minus Vc equal to Vm minus 0.7 volts. Then we can getting minus Vm plus 0.7 volts. Okay, with respect to this equation, we are draw the output waveform of this negative clamper unbiased circuit. Okay, these are the input and output waveforms of the negative clamper unbiased circuit with the practical diode. Okay, and we know that the output voltage of this circuit is V out equal to V in minus Vm plus 0.7 volts. Okay, and here this signal is given to input of this negative clamper circuit. Okay, and during this instant, the diode is on. Okay, at the time the output voltage of the negative clamper circuit V out equal to 0.7 volts. Okay, therefore here we are draw the waveform is 0.7 volts. Okay, and after reaching this instant, in this overall duration, the diode is operated in the reverse bias condition. Therefore, the diode is open circuited. Okay, at the time we are get the output voltage equal to V in minus Vm plus 0.7 volts. For example, the input voltage of the negative clamper circuit, for example, is 0 volts. At that time we are getting V out equal to minus Vm plus 0.7 volts. Therefore, at this instant, here we have the output voltage equal to minus Vm plus 0.7 volts. Okay, and for example, we are giving the input voltage equal to minus Vm, then V out equal to, we will get the minus Vm plus 0.7 volts. Therefore, we are getting output voltage equal to minus 2 Vm plus 0.7 volts. Okay, at that instant, the output voltage of the negative clamper circuit is minus 2 Vm plus 0.7 volts. Okay, and again we are giving the input voltage equal to 0, and we are getting the output voltage equal to minus Vm plus 0.7 volts. And again at this instant we are get the output voltage equal to 0.7 volts. Okay, here we will mention the output voltage equal to 0.7 volts. Okay, so in this way we will get the output waveform of the negative clamper circuit. Okay, and next we discuss some important points about the negative clamper unbiased circuit. Okay, that is, for example, here we are draw the one circuit. Okay, this circuit having the components are the input voltage, and we are connecting the one capacitor, and here we are connecting one diode. Okay, and here we are take the output. Okay, and in this negative clamper unbiased circuit, how much voltage is stored across the capacitor, that much of voltage is negative clamped to the output side. Okay, for example, in the previous classes we are giving them square waveform is the input. Okay, and this capacitor can store the voltage equal to Vm. Okay, and we will get the output voltage is clamped to negative side up to we will get the voltage equal to minus 2 Vm, and here we get the output equal to 0. It means that the same input signal is clamped to the negative side. Okay, and here how much DC voltage is added to the given input signal is depending upon the voltage storage across this capacitor. Okay, and with respect to the this circuit, we conclude one important point is some of the examinations directly they are giving the circuit is like this, and they asking them this circuit is either the positive clamper circuit or the negative clamper circuit. Okay, here in this circuit the diode cathode terminal is connected to the ground. It means that the input voltage is clamped to the negative side. Okay, so based on this diode position we are identify this circuit is the positive clamper circuit or the negative clamper circuit. Okay, thank you.